Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are constructing confidence interval for the mean of a population, where the shape of the population is unknown, but the standard deviation of the population is known and the sample size is sufficiently large. So let's start the lecture. Confidence interval for the mean of a population whose shape is unknown, but the population standard deviation is known and the sample size is sufficiently large. So now we are constructing confidence interval for the mean of a population whose shape is unknown, but the population standard deviation is known and the sample size is also sufficiently large. So as for large sample size, the sampling distribution of the sample mean x bar is approximately normal irrespective of the parent population, the population from which sample is taken out. So if this parent population is normal or non-normal, but if the sample size is sufficiently large, then the sampling distribution of the sample mean x bar will be approximately normal. And then in the construction of confidence interval, we will follow the same steps that we are following under standard normal distribution for the construction of confidence interval. So now, on the basis of central limit theorem, the sampling distribution of the sample mean for large sample size will be approximately normal. So for this purpose, we are taking a numerical example in order to convey you the meaning of this statement. So let's take a numerical example. Okay, so these are data information. The population shape is unknown. Population standard deviation sigma is equal to 6. Sample mean x bar is equal to 100. Sample size n is equal to 36. Confidence level 1 minus alpha is equal to 98%. So now these are data information and we are constructing 98% confidence interval for the mean of the population. So let's proceed. Here the shape of the population is unknown, but the population standard deviation is known. So for sufficiently large sample size, the central limit theorem states that the sampling distribution of the sample mean x bar will be approximately normal with mean mu and standard deviation sigma over under the root n, because the population standard deviation is known. If this sigma, the population standard deviation, had been unknown, so then we would replace it by its sample counterpart, that is S. So now for the confidence interval for the population mean, we will use the expression x bar plus minus z alpha by 2 into sigma over under the root n. So now we will use this expression. Now plugging the value in this statement, x bar is equal to 100 plus minus z alpha by 2 is the tabular value for the confidence level. The confidence level in this case is 98% and the table value for 98% is 2.33. So we will write 2.33 for z alpha by 2. Now sigma is equal to 6, so we will write 6 divided by under the root n, and n in this case is 36. So now if we simplify this, so we will get 100 plus minus 2.33 and this will give us 1. So now in the final step, what we will do, we will subtract 2.33 from 100 first. It means 100 minus 2.33. So this will give us the lower limit of the interval and we will add 2.33 in 100. So this will give us 100 plus 2.33. So if we solve this, so this will give us 97.67 and this will give us 102.33. So these are the two limits of the interval. Now these are the two limits of the interval and this is the interval about which we are 98% confident that it will contain the mean of the population. So this was all about the confidence interval for the mean of a population whose shape is unknown, but the population standard deviation is known, and the sample size is sufficiently large. So the main objective of this lecture was to convey you that even though if the shape of the population is unknown, but if the sample size is large, then the sampling distribution of the sample mean x bar will be approximately normal, and hence we can construct the confidence interval for the population mean the same way as we did in the case of normal population with known standard deviation. So this was the whole story behind this lecture. I hope this will help you in the construction of confidence interval for the mean of a population whose shape is unknown but a sample size taken from it is sufficiently large. Thank you for watching the video.